Information science is an interdisciplinary field primarily concerned with the analysis, collection, classification, manipulation, storage, retrieval, movement, dissemination, and protection of information. Practitioners within the field study the application and usage of knowledge in organizations, along with the interaction between people, organizations and any existing information systems, with the aim of creating, replacing, improving, or understanding information systems. Information science is often considered a branch of computer science. However, it predates computer science and is actually a broad, interdisciplinary field, incorporating not only aspects of computer science, but often diverse fields such as archival science, cognitive science, commerce, communications, law, library science, museology, management, mathematics, philosophy, public policy, and the social sciences. Information science should not be confused with information theory or library science. Information theory is the study of a particular mathematical concept of information. Information science as an academic discipline is often taught in combination with library science as library and information science. Information science deals with all the processes and techniques pertaining to the information life cycle, including capture, generation, packaging, dissemination, transformation, refining, repackaging, usage, storage, communication, protection, presentation, etc., in any possible manner. Foundations. Scope and approach. Information science focuses on understanding problems from the perspective of the stakeholders involved and then applying information and other technologies as needed. In other words, it tackles systemic problems first rather than individual pieces of technology within that system. In this respect, one can see information science as a response to technological determinism, the belief that technology develops by its own laws, that it realizes its own potential, limited only by the material resources available and the creativity of its developers. It must therefore be regarded as an autonomous system controlling and ultimately permeating all other subsystems of society. Many universities have entire colleges, departments or schools devoted to the study of information science, while numerous information science scholars work in disciplines such as communication, computer science, law, library science, and sociology. Several institutions have formed an iSchool caucus, but numerous others besides these also have comprehensive information foci. Within information science, current issues as of 2013 update include human-computer interaction, groupware, the semantic web, value-sensitive design, iterative design processes, the ways people generate, use and find information. Definitions of information science. An early definition of information science states, information science is that discipline that investigates the properties and behavior of information, the forces governing the flow of information, and the means of processing information for optimum accessibility and usability. It is concerned with that body of knowledge relating to the origination, collection, organization, storage, retrieval, interpretation, transmission, transformation, and utilization of information. This includes the investigation of information representations in both natural and artificial systems, the use of codes for efficient message transmission, and the study of information processing devices and techniques such as computers and the programming systems. It is an interdisciplinary science derived from and related to such fields as mathematics, logic, linguistics, psychology, computer technology, operations research, the graphic arts, communications, library science, management, and other similar fields. It has both a pure science component, which inquires into the subject without regard to its application, and an applied science component, which develops services and products. Some authors use informatics as a synonym for information science. This is especially true when related to the concept developed by A. I. Mikhailov and other Soviet authors in the mid-1960s. The Mikhailov School saw informatics as a discipline related to the study of scientific information. Informatics is difficult to precisely define because of the rapidly evolving and interdisciplinary nature of the field. Regional differences and international terminology complicate the problem. Some people note that much of what is called informatics today was once called information science, at least in fields such as medical informatics. For example, when library scientists began also to use the phrase information science to refer to their work, the term informatics emerged in the United States as a response by computer scientists to distinguish their work from that of library science. In Britain as a term for a science of information that studies natural, as well as artificial or engineered, information processing systems. Another term discussed as a synonym for information studies is information systems. Brian Campbell Vickery's information systems places information systems within is. Ellis, Allen, and Wilson, on the other hand, provide a bibliometric investigation describing the relation between two different fields, information science and information systems. Philosophy of information studies conceptual issues arising at the intersection of computer science, information technology, and philosophy. It includes the investigation of the conceptual nature and basic principles of information, including its dynamics, utilization and sciences, as well as the elaboration and application of information theoretic and computational methodologies to its philosophical problems. Ontology in computer science and information science. An ontology formally represents knowledge as a set of concepts within a domain, and the relationships between those concepts. It can be used to reason about the entities within that domain and may be used to describe the domain. More specifically, an ontology is a model for describing the world that consists of a set of types, properties, and relationship types. Exactly what is provided around these varies, but they are the essentials of an ontology. There is also generally an expectation that there be a close resemblance between the real world and the features of the model in an ontology. In theory, an ontology is a formal, explicit specification of a shared conceptualization. An ontology renders shared vocabulary and taxonomy which models a domain with the definition of objects and/or concepts and their properties and relations. Ontologies are the structural frameworks for organizing information and are used in artificial intelligence, the semantic web, systems engineering, software engineering, biomedical informatics, library science, enterprise bookmarking, and information architecture as a form of knowledge representation about the world or some part of it. The creation of domain ontologies is also fundamental to the definition and use of an enterprise architecture framework. Careers. Information scientist. An information scientist is an individual, usually with a relevant subject degree or high level of subject knowledge, providing focused information to scientific and technical research staff in industry, a role quite distinct from and complementary to that of a librarian. The title also applies to an individual carrying out research in information science. Information professional. And information professional is an individual who preserves, organizes, and disseminates information. Information professionals are skilled in the organization and retrieval of recorded knowledge. Traditionally, their work has been with print materials, but these skills are being increasingly used with electronic, visual, audio, and digital materials. Information professionals work in a variety of public, private, non-profit, and academic institutions. Information professionals can also be found within organizational and industrial contexts, performing roles that include system design and development and system analysis. History. Early beginnings. Information science, in studying the collection, classification, manipulation, storage, retrieval and dissemination of information has origins in the common stock of human knowledge. Information analysis has been carried out by scholars at least as early as the time of the Abyssinian Empire, with the emergence of cultural depositories, what is today known as libraries and archives. Institutionally, information science emerged in the 19th century along with many other social science disciplines. As a science, however, it finds its institutional roots in the history of science, beginning with publication of the first issues of Philosophical Transactions, generally considered the first scientific journal, in 1665 by the Royal Society. The institutionalization of science occurred throughout the 18th century. In 1731, Benjamin Franklin established the Library Company of Philadelphia, the first library owned by a group of public citizens, which quickly expanded beyond the realm of books and became a center of scientific experiment, and which hosted public exhibitions of scientific experiments. Benjamin Franklin invested a town in Massachusetts with a collection of books that the town voted to make available to all free of charge, forming the first public library. Académie de Chirurgie published memoirs pour les chirurgiens, generally considered to be the first medical journal, in 1736. The American Philosophical Society, patterned on the Royal Society, was founded in Philadelphia in 1743, as numerous other scientific journals and societies were founded. Alois Sennefelde developed the concept of lithography for use in mass printing work in Germany in 1796. 19th century. By the 19th century, the first signs of information science emerged as separate and distinct from other sciences and social sciences, but in conjunction with communication and computation. In 1801, Joseph Marie Jacquard invented a punched card system to control operations of the cloth-weaving loom in France. It was the first use of memory storage of patterns system. As chemistry journals emerged throughout the 1820s and 1830s, Charles Babbage developed his difference engine, the first step towards the modern computer, in 1822, and his analytical engine by 1834. By 1843, Richard Hoe developed the rotary press, and in 1844 Samuel Morse sent the first public telegraph message. By 1848, William F. Poole begins the Index to Periodical Literature, the first general periodical literature index in the U.S. In 1854, George Boole published an investigation into laws of thought, which lays the foundations for Boolean algebra, which is later used in information retrieval. In 1860, a congress was held at Karlsruhe Technische Hochschule to discuss the feasibility of establishing a systematic and rational nomenclature for chemistry. The Congress did not reach any conclusive results, but several key participants returned home with Stanislaw Canizzaro's outline, which ultimately convinces them of the validity of his scheme for calculating atomic weights. By 1865, the Smithsonian Institution began a catalogue of current scientific papers, which became the International Catalogue of Scientific Papers in 1902. The following year, the Royal Society began publication of its catalogue of papers in London. In 1868, Christopher Scholes, Carlos Gliddon, and S. W. Soule produced the first practical typewriter. By 1872, Lord Kelvin devised an analog computer to predict the tides, and by 1875 Frank Stephen Baldwin was granted the first U.S. patent for a practical calculating machine that performs 4 arithmetic functions. Alexander Graham Bell and Thomas Edison invented the telephone and phonograph in 1876 and 1877 respectively, and the American Library Association was founded in Philadelphia. In 1879, Index Medicus was first issued by the Library of the Surgeon General, U.S. Army, with John Shaw Billings as librarian, and later the library issues Index Catalog. which achieved an international reputation as the most complete catalogue of medical literature. European documentation, the discipline of documentation science, which marks the earliest theoretical foundations of modern information science, emerged in the late part of the 19th century in Europe together with several more scientific indexes whose purpose was to organize scholarly literature. Many information science historians cite Paul Otlet and Henry Lafontaine as the fathers of information science, with the founding of the International Institute of Bibliography in 1895. A second generation of European documentalists emerged after the Second World War, most notably Suzanne Bryant. However, information science, as a term, is not popularly used in academia until sometime in the latter part of the 20th century. Documentalists emphasize the utilitarian integration of technology and technique towards specific social goals. According to Ronald Day, as an organized system of techniques and technologies, documentation was understood as a player in the historical development of global organization in modernity, indeed, a major player inasmuch as that organization was dependent on the organization and transmission of information. Otlet and Lafontaine not only envisioned later technical innovations but also projected a global vision for information and information technologies that speaks directly to post-war visions of a global information society. Otlet and Lafontaine established numerous organizations dedicated to standardization, bibliography, international associations, and consequently, international cooperation. These organizations were fundamental for ensuring international production in commerce, information, communication, and modern economic development, and they later found their global form in such institutions as the League of Nations and the United Nations. Otlet designed the Universal Decimal Classification, based on Melville Dewey's decimal classification system. Although he lived decades before computers and networks emerged, what he discussed prefigured what ultimately became the World Wide Web. His vision of a great network of knowledge focused on documents and included the notions of hyperlinks, search engines, remote access, and social networks. Otlet not only imagined that all the world's knowledge should be interlinked and made available remotely to anyone, but he also proceeded to build a structured document collection. This collection involved standardized paper sheets and cards filed in custom-designed cabinets according to a hierarchical index and a commercial information retrieval service. Users of this service were even warned if their query was likely to produce more than 50 results per search. By 1937, documentation had formally been institutionalized, as evidenced by the founding of the American Documentation Institute, later called the American Society for Information Science and Technology. Transition to modern information science. With the 1950s came increasing awareness of the potential of automatic devices for literature searching in information storage and retrieval. As these concepts grew in magnitude and potential, so did the variety of information science interests. By the 1960s and 70s, there was a move from batch processing to online modes, from mainframe to mini and microcomputers. Additionally, traditional boundaries among disciplines began to fade and many information science scholars joined with library programs. They further made themselves multidisciplinary by incorporating disciplines in the sciences, humanities and social sciences, as well as other professional programs, such as law and medicine, in the curriculum. By the 1980s, large databases, such as Grateful Med at the National Library of Medicine, and user-oriented services such as Dialog and CompuServe, were for the first time accessible by individuals from their personal computers. The 1980s also saw the emergence of numerous special interest groups to respond to the changes. By the end of the decade, special interest groups were available involving non-print media, social sciences, energy and the environment, and community information systems. Today, information science largely examines technical bases, social consequences, and theoretical understanding of online databases. Widespread use of databases in government, industry, and education, and the development of the Internet and World Wide Web.